In this video, we're looking at exponential functions and their graphs. So for any real number x, an exponential function is a function of the form f of x equals a times b to the x. So a big difference between an exponential function and a polynomial function is that now our variable is in that exponent position. Some properties of this exponential function: a is a non-zero real number called our initial value. B is any positive real number such that b does not equal 1. The domain of our exponential functions is all real numbers, so there's never going to be a restriction on our domain. The range of f is all positive real numbers if a is positive, and the range of f is all negative real numbers if a is negative. The y-intercept is 0a, and the horizontal asymptote is y equals 0. Graph the exponential functions, plotting at least 3 points. For each function, give the domain in interval notation, the range in interval notation, and the equation of the horizontal asymptote. So we've got f of x equals 2 to the x. We're going to make a table of values to create some points. We're going to plot negatives 1, 0, and 1. These are pretty standard landmark points for our exponential functions. 2 to the negative 1 power is 1/2. 2 to the 0 power is 1. Remember that anything raised to a power of 0 is 1. And 2 to the 1 power, or first power, is 2. When I graph this, I'm going to divide my grid up a little bit just to spread these points out. So I'm going to go by 2 ticks for everyone. So plotting my points, we're at negative 1, 1/2, 0, 1, and 1, 2. And my graph looks like this. The domain of this function is negative infinity to positive infinity. The range is from 0 to positive infinity. We are not including 0 because 0 is our horizontal asymptote. That equation for the horizontal asymptote being y equals 0. F of x equals 1/2 to the x. So same thing. We're going to just create a table of values using negative 1, 0, and 1 for x values. 1/2 raised to the negative 1 power is 2. 1/2 to the 0 power is 1. And 1/2 to the first is 1/2. Dividing my grid up the same way, I've got a point at negative 1, 2, 0, 1, 1, 1/2. And there's the graph of my function. The domain is all real numbers, so negative infinity to positive infinity. The range is 0 to positive infinity. And our horizontal asymptote is y equals 0. Now, I do want to point out the relationship between these two functions, 2 to the x and 1/2 to the x. You'll notice that they had very similar ordered pairs, but the 2 and the 1/2, that reciprocal, what we're seeing is that it's actually reflecting about that vertical axis, that y-axis. We're also illustrating some additional rules for the value of the base of our exponential functions. If b is greater than 1, then we do see a function that's increasing like we have in example A. And if b is between 0 and 1, remember b has to be positive, but it's not equal to 1. So between 0 and 1 exclusively, then we see a decreasing function like we have in example B. F of x equals negative 3 to the x. We're going to graph this using some transformation. So we're going to identify our parent function is y equals 3 to the x. And that transformation is the multiplication of a negative 1. When we multiply by that negative 1, it's going to reflect about the x-axis. For our table of values, we're going to create a table of values for that parent function. So we're going to use -1, 0, and 1 for x. 3 to the -1 power is 1/3. 3 to the 0 is 1. 3 to the first power is 3. So I'm going to start by plotting my transformations, or plotting my parent function. So -1, 1/3 is about here. 0, 1, 1, 3 is right here. So this graph in green is that parent function y equals 3 to the x, and our transformation just flips it about the x-axis, so reflects over the x-axis. Again, anytime you've got multiple graphs on one grid, just make sure you label those graphs. The domain, -infinity to +infinity. Quick observation, we haven't had a different domain because the generic form of that exponential function is defined on all real numbers. Any function in that family is also going to be defined on all real numbers. The range, however, is now different. It's going to be -infinity to 0, but our horizontal asymptote is still y equals 0. When we think about those horizontal asymptotes, we've had the same horizontal asymptote for the first 3 examples. We won't see a change in our horizontal asymptote until we see a vertical shift to our parent function. All right, the next one, we have f of x equals 3 to the x plus 2 minus 2. So we're going to keep that same parent function of y equals 3 to the x. And when we identify our transformations, the +2 in that exponent is going to be a horizontal shift to the left 2 units. And that -2 at the end is going to shift the function down 2 units. Using that same table of values for my parent function, 3 to the negative first power is 1/3. 3 to the 0 is 1. 3 to the first power is 3. In green, I'll graph that parent function, -1, 1/3, 0, 1, 1, 3. And those 3 points, I'm going to move them left 2 and down 2. Just be careful of your scaling because I've gone by half increments. I do need to just be more careful there. So in purple is our graph of f of x, which we're labeling. The domain, -infinity to +infinity. Our range, it starts at -2 and goes all the way to +infinity. And now our horizontal asymptote, because of that vertical shift down, is y equals -2.